I'm giving you the property as in a conditional statement if then. So if it's addition property of equality, what I'm trying to show you is that there should be some type of adding. Where's my, oh, I see what happened. Move it around. So if you look here, if A equals B, then A plus 3 and B plus 3 are equal. Because what they're showing is they added the equal amount, the same amount, to both sides of the equal sign. Now, this can happen with a math sentence dealing with angles. The measure of angle 1 equals the measure of angle 3. Now they're adding the measure of angle 2 to both sides. So this happens also with subtraction. What you did last year, for example, write this example in this box. You had x plus 5 equals 3. To solve for x, what would you need to do to get the x isolated and by itself?
Subtract 5.
So we would subtract 5 on both sides. Because we did it on both sides of the equal sign, that canceled our constant and we got x equals negative 2. Because I see that subtraction used on both sides of the equal sign, that's using your subtraction property of equality. Instead of writing out property of equality, we just say POE. Okay. Now, multiplication. If A equals B, then 3A equals 3B. They're showing you that they multiply 3 times A and 3 times B on both sides. Now, in geometry, we use that property multiplying or doubling lengths. AB is the length of AB. I do 2 times AB, it would be the same as 2 times XY. Because I'm showing multiplication of 2, the same amount on both sides of the equal sign, then it's a property of equality. Now last year, you solved for x. So if I have 4x equals 16, to get to my solution, what would we have to do to show? Divide both sides by 4. So show that on your notes. Because I'm seeing division of 4 on both sides, that's how we get to x equals 4. Now, we have formulas in geometry where you might have to solve for a part. This is the formula to find the median in a trapezoid. The median is twice the median equals the sum of the bases, base 1 plus base 2. If I want to solve for just the median, I would divide both sides by 2. Get rid of the 2 in front of the parentheses. So show that on your notes. This would cancel out that 2 in the front, and we get the formula for the median. The median equals base 1 plus base 2 divided by 2. So basically, we're doing the average of the sum. If there's 2 parts and I divide it by 2, that's taking the average. Now, in last year, you did substitution by plugging it in. So to show substitution, we need to have these parentheses and a number inside. Because I tell you x equals 2, I'm just drawing an arrow to plug it back in. Yeah. Say that again.
I did.
What's the number next to 35?
35 degrees.
Oh, sorry.
Yeah, it's a degree sign. And then if I see parentheses, I should know to use the distributive property. So this is saying 2 times x plus 2 times 5, which is why I get the expression 2x plus 10. Okay. Another example of showing that with some geometric relationships would be like if I had, the formula for area of a trapezoid is the height times the sum of the bases, base 1 plus base 2 all over 2. Yeah, stop talking. So just distribute here. We can distribute the height, the variable that represents the height here. So that would be HB1 plus HB2 all over 2. And then anytime you have to combine like terms, that should be only on the same side of the equal sign, either only on the left or only on the right. And usually we associate combine like terms with simplifying the expression. So we're going to use these properties with some geometric relationships, but I'm going to show you how our new properties are similar to geometry with diagrams. So on the second page, you should have picked up 2 pages. Yeah. It's in there. It's in there. It's up there. It's up there now. It's up there on the wall. It's when we have a mirror image in the equality statement. So in the equal sign. If x is a number, then x has to equal x, like, unless I'm solving an equation. This is the same thing as saying y equals y. Now, with algebra, with the geometry, for example, let's say we're talking about a segment AB. A reflexive statement would be AB equals AB, the exact same thing. Or you could say AB equals BA. Because in naming a segment, the order of the letters doesn't matter. So as long as I'm stating the exact same thing, we have the reflexive property. So here is how it's shown on diagrams. This is a part I guess I need you to really focus on. Because when will it be used? It's with 2 figures shared something. So this first figure that I'm trying to show you is this big blue triangle for me. I just kind of outlined it in blue. We have a big triangle and we have a little triangle. That's the red one here. And angle 1's, if you notice, angle 1 is in both triangles. Okay? So because they're overlapping and they share that angle, then angle 1 is congruent to angle 1 using the reflexive property. If you have overlapping figures, then you're going to have a shared angle. So your angle 1 here in this diagram, right there, this is the shared angle. Anytime you have a shared, anything shared, you have to use the reflexive property. You have to state the part that is shared in the diagram, and your reason for stating it would be reflexive property. So the first thing that's missing, because they're talking about this triangle, I need you to add the C for this top point up here. The right triangle is on the left here, and then we have a gray triangle on the right. They share this segment here going through the middle. That is your shared segment. So I'm just going to draw an arrow pointing to that. That is the shared side. If you have a shared side, then you're going to have a reflexive property of congruency. That shared side is CD. CD is congruent to CD, and this would be bi reflexive, and I'm just going to abbreviate that, POC, property of congruency. Now, our symmetric property is whenever we switch the order of the equality statement. Okay. If AB equals CD, then CD equals AB. So an example of that says Jean is the same height as Pedro. Then I can say Pedro's the same height as Jean. I just switched them order around, but it still has the same meaning. So if CD is congruent to FG, what does it switch to? Yeah, FG is congruent to CD. That's using the symmetric property. Angle 1 congruent to angle 2 switches to what? Yeah, good. Angle 2 congruent to angle 1. So anytime I switch something around, that's using symmetric property. Now, transitive property says if my segment AB is equal to CD and CD is equal to EF, do you see how they have this common part there? We're going to take that part out and we get AB is equal to EF. So we go from first, yes, exactly, to last. This is exactly the same as law of syllogism. Yes. The transitive property is the same as the law of syllogism. Law of syllogism said P implies Q and Q implies R. Then I can take out that middle common part Q and conclude P implies R. If P, then R. So in a race, if I know person A beats person B and person B beats person C, then what can I conclude that person A also do? Yeah. A beats C. SYLLOGISM. Mhm. So I know on your notes this POC, the reflexive property of congruency, is missing. Okay. All you really need to know for this, this information is saying the exact same thing. Here's what I need you to know. Add this to the bottom of your notes right here, or in that box. If you see this symbol, that's the congruency symbol, then you have to say POC, not POE. If you see the equal sign, okay, then you can say property of equality. So pay attention to your signs to pick the right property, okay? Congruency goes with POC, equal goes with POE. Just add those two facts, okay? So these two sheets go into your spiral. We're going to finish unit 2 today, well, tomorrow really. So please get, okay, so this section above here, these are answer choices or answer bank.
Is this part of the U?
Yeah, and you have the table content. So just look at the table content. So here's how you can break it down. So I would first look at your symbol. Like that symbol is a congruency symbol. So this is going to be a POC, property of congruency. All right, then I read the statement. Angle P is congruent to angle P. This is an example of a mirror image. Nothing has changed. So what property is like a mirror? Yeah, so you can abbreviate, guys. So look at your symbol first to determine POE versus POC, and then read the statement. So like, I'm going to jump to number 3, guys. This has equal signs here. So that means this is going to be a POE. All right, so then I look at my statement. It says RS is equal to TW. If RS is equal to TW, then TW equals RS. What happened in the statement? Yeah, they just switched it around. If it's a switch, then that is symmetric. Yes, and I'm just gonna abbreviate that SYMM. Okay. Now, if it's an equation where they're solving for a variable, to help you determine the property, think of what step you had to take to solve it. So if x plus 5 equals 16, what would I have to do to solve for x or isolate the x? Yeah, since we have to show subtraction to get x equals 11, this would be subtraction. I'm going to abbreviate that. Property of equality. So think, if there's an equation, you have to think, what step would I have to take to solve for the variable or to get the next one? So 1 through 10 is using one of the properties above the page on the top. The last section, this is different right here. It says use the property stated. So in this section, they're going to state off what property they want you to use, and they want you to use that property to fill in the blank. If it's a reflexive property, it's a mirror image. If it's reflexive. Yeah, SE equals SE, exactly. Okay. Like here, they want you to use symmetric property. What do we do in the symmetric property? You switch them. So since they told us how it ended, we need to switch it back. So the measure of angle JKL is equal to the measure of angle RST. Everyone's going to turn in this worksheet before they leave, and I'm grading it. Okay. So just put it in the tray when you're done. You can look at your notes. You can check with the neighbor. But this is due before you go.